everyone, it's good to be back for lesson 4. Today we're going to be taking a look at limits with trigonometry. And so up here on the board we've got our unit circle, and yes, you better take a picture of it because it'll last longer. IB exams, AP exams, college courses do not allow you to bring a unit circle, and so you won't be referencing that, but you will still be expected to be able to come up with these values and unit circle values and trig values. So we're going to do a really quick review check on this. This would be a great time to pause the video and try what you see on the board for yourself. And I'm going to go ahead and get working on it as well, so whenever you're ready, hit play. Alright, for the first one, what I like to do when I'm thinking of the unit circle is I first like to figure out where I'm at on the circle. And so I actually, whether it's in my head or actually on the paper, a lot of times I'll actually draw it out. I like to first figure out where the heck am I on the circle. And so 3 pi over 4 is sitting right over here. It's right in the middle of quadrant 2. And so at that point, my cosine value, please remember that's an x value. That value is negative root 2 over 2. Okay, head down to the next one, 5 pi over 3. That's just short of 6 pi over 3, which is 2 pi. So that means we're right down in here. We're looking for a sine value. Please recall that that's a y value. And at this point, we have a y value of negative root 3 over 2. Okay, let's go to the tangent. Tangent, 7 pi over 6. The way I think about it, that's just a little, 7 over 6, just a little bit bigger than 1. And so that's going to be right in here. Tangent, recall that's a y value divided by an x value. Looks like our y value is negative 1/2 and our x value is negative root 3 over 2. And you better believe that we expect you to simplify it. So let's do that. Flip this and multiply it. When you do so, negatives are going to cancel out, the 2's are going to cancel out, and you're going to be left with 1 over root 3. We're going to go ahead and rationalize that denominator so that we get root 3 over 3. Okay. Continuing up here, we're going to go ahead and hit all the main trig functions. So secant, please remember that secant is 1 over cosine, or 1 over an x value. Pi, that's over here, and our cosine value there is negative 1. So we get 1 over negative 1, which is just negative 1. Cosecant, remember that that's 1 over sine, and so we're doing that at the same location. 1 over sine, the sine value over here is 0, so when we get 1 over 0, that is not defined. And I'm going to put an empty set there for it. Cotangent, for the tangent we had y over x, so this is a reciprocal function is what we call it, so that would be x over y. Okay, and as far as x over y goes, this is at pi over 6. Pi over 6 is right there. My x value is root 3 over 2. And my y value is 1/2. And so this turns into just root 3 when you flip that and multiply it. If you're not understanding it, actually flip that bottom fraction, write it out so they're multiplied together, and you'll see the 2's cancel out. Okay, so there's that one. Okay, we're going to add a little bit to the trig. We have a couple of identities here. In about a month, I'll be posting a video about L'Hopital's rule. We're going to explain this. Until we've learned about derivatives, that's not going to make a whole lot of sense. So for today, we're just going to take these as fact. We're going to use them, and then we're actually going to derive them a little bit later when we have a little bit more understanding of calculus. So you're going to want to have these in your notes. We're going to be identifying them as some exercises here in just a minute. Okay, let's do a little bit of practice. We'll do a few examples. It's going to be a little bit of a short video today, and then we'll be done. So here we go. Just like with any other limit, the first thing we want to try is we want to try to actually substitute in that value that we're approaching. We're approaching 0. That would put a 0 in the denominator, which creates a problem. So we're going to have to do some sort of a simplification or an algebra trick or some sort of trickery like that. So what I'm seeing here, I've got a cosine, and I remember that tangent has something to do with sine and cosine, so I want to write that out. Okay, so limit as theta approaches 0 of cosine times sine over cosine, don't forget your thetas in there, divided by theta. And so right away we see cosines can cancel out, there they go. Moving down, I now recognize that I have sine theta over theta, and theta is approaching 0. So that's exactly what that identity was on the previous page. So without any more thinking, look right there, we can see that this is going to be 1. And that's done. That's all it is. On to the next one. When we try to plug in a pi here, let's see if that works. Remember our unit circle, pi is over here on the left-hand side, and we're talking about the x value, so that looks like that's negative 1. So when I make this substitution, what I get is pi over negative 1 or negative pi. No big deal. Next one, plug in pi here. Hey, that's the same thing. Not a problem. So we have cosine of pi, which is negative 1. And then this last one, this is sort of a standard limit exercise with trigonometry, dealing with a sign where you have different coefficients in the numerator and denominator. So there's a little bit of an algebra trick to this. What we're going to do is we're going to first factor out that 4 out to here. And once we have that, well, let me rewrite for a second. So I have 1/4 limit x approaches 0 sine of 7x over x. Okay. Now a note about the identities we looked at a minute ago. Yes, I know that this says x and that says x. But what that really means, what a mathematician interprets that as, is it just says whatever's written right here, we need the same exact thing to be written there. And if that happens, then we know that our limit is going to be 1. So this could just as easily have been, I mean, imagine if x was defined to be 7 theta, or 2 theta, I guess is what I ended up writing. So if that had said 2 theta and that also said 2 theta, they're both x, they're both the same thing, so that's sufficient. Now with that in mind, our approach to this is that we want to get these to match. And so, well, is it easier to get that 7 to go away, or is it easier to just put a 7 there? Well, let's just put a 7 there and see what happens. And so right away, recognize, I've just broken a rule of math. I've magically changed what it says, I've changed what it means, and so we have to balance that out. Anytime you change something, you have to balance it out. So I've just divided this by 7. I've put it in the denominator, and so in order to balance that, I need to do the opposite of dividing. I need to also multiply by 7. And so now, ultimately, all I've done, I've multiplied by a fancy form of the number 1. And we know that multiplying by 1 doesn't change anything. So with that in mind, here we are. That's in the way though. So I'm going to factor this out in the same exact way we factored the 4 out right there. And so what I now have is 7/4 limit as x approaches 0 sine of 7x over 7x. And so now we have that situation I was talking about where these two things match. And so what that indicates is that this little chunk of algebra right here, that is 1. Based on our previous identity, we have a 7/4 right here, and it should be no surprise to you that 7/4 times 1 is 7/4. So, let's make a connection. Notice how the answer relates to the initial question. Do you see how, right here, that answer is just sitting there? It was there the whole time. But of course, we're going to ask that you show your work. This is a little trick that I'm pointing out to you, because once you do all your work, if you already know what the answer is going to be, then you know when you're right. Okay? That's all for today. Hope you enjoyed the assignment, hope you enjoyed the lesson, and we'll see you next time.